are in listen-only mode.
Hello, everyone. Welcome to today's webinar. Thanks for joining us. Today's webinar is LED lighting for industrial applications. Don't wait to make the switch. I'm Ann Cosgrove, the editor-in-chief of Facility Executive Magazine, and this webinar is presented by CREE. So before we get started, I would like to cover a few housekeeping items. Please note the control panel that's on your screen. This is where you can submit questions in the question box. Our speaker will address them after the presentation, but please send those questions in at any time and we will address them. Please make sure the orange arrow on the left side of your control panel has the control panel expanded, and then you can access the question box there. Also, if you have a technical difficulty, audio or video for any reason, please send us a message there and we will try to address it with you directly right away. I'd like to introduce your speaker today, Ryan Loggins, and Ryan is a product portfolio manager at CREE. And CREE is a market-leading innovator of lighting class LEDs, LED lighting, and semiconductor solutions. With more than 7 years of lighting and technology experience, Ryan leverages his knowledge and understanding of commercial and industrial markets to position the technical, business, and end-user benefits of LED lighting. And at CREE, Ryan works closely with lighting agents, specifiers, and end customers to drive thought leadership and oversee the development of industry-leading solutions that will solve real-world customer problems ahead of typical market trends. So we're looking forward to hearing from Ryan today, and we hope to get some great questions from you at the end. Thanks very much. Hi, Ryan. How are you?
Good. Thank you for the introduction. Well, to start things off, as mentioned, today's our topic is going to be fixing the billion-dollar hole in the roof, the end of inefficient high bay lighting. Specifically, as mentioned, I'm typically related or most closely involved in industrial applications, but do span out from that scope from time to time. So a lot of this information would actually apply to other applications as well, but that's really where my primary focus is, just in case that crosses your mind. So taking a look at our agenda here, trying to get my screen to advance. I do apologize. There we go. So what we'll discuss today is really the challenges and the limitations of traditional light sources, and clearly the advantages of LED technology for industrial applications and why now is the time to make the switch, and really what to look at when you're selecting your LED lighting solutions, and what's next within the industrial lighting space. So starting off, first we'll take a look at the challenges and limitations of the incumbent technologies. I think probably most people are all familiar with what other light sources are out there, including metal halides and fluorescents. But today, with the energy costs on the rise, as well as the expectations to meet production goals and to provide safe and comfortable working conditions, it's really created a revolution in the air. And lighting typically accounts for more than a quarter of a commercial building's electricity usage each year, and that figure can rise even higher for intensive use with 24/7 applications. So because of this, people are looking for alternatives for not only a better lighting experience, but also because they're looking for energy savings and ways that they can cut down on their overall energy consumption. So making the right choice in high bay lighting fixtures can cut your lighting cost as much as by 65%, while eliminating less obvious bottom line penalties, including maintenance costs such as relamping and lighting related work stoppages and disposal. So with so much at risk, what is the right choice? Is it metal halide? Is it fluorescent? Or is it LED? So taking a closer look at metal halide, when you're looking at these, there's a couple of things to keep in mind when you want to make sure that you're making the right choice. And the HID fixtures today make up about 50% of the installed base of the high bays found in warehouses, manufacturing centers, gymnasiums, convention centers, and other large open spaces. So the biggest downfall of HID fixtures is that first and foremost, they're energy hogs. And a typical 400 watt metal halide fixture typically consumes up to about 450 watts of energy. So when you look at the national average of about 11 cents per kilowatt hour, the energy cost alone adds up very, very quickly. So HID fixtures also generate a lot of heat. So, and that's really where about 10 to 15% of their energy consumption actually goes to, is actually displaced heat because of their inefficient designs, which can also affect your energy consumption in a negative way by driving up your HVAC cost. Also, when you're looking at HID fixtures, they have a very short lifespan in comparison to some of the other light sources out there. And typically their effective illumination or their rated life is about 20,000 hours. So after 16 hours a day, a 20,000 hour fixture burning for 16 hours a day would produce less than half of its initial lumens in less than 24 months. And because the performance drops off so quickly and it's prone to failures, including lamp and ballast changes, what you end up doing is actually dramatically overlighting your space on day one. And then by the time the design's lifetime is actually over, then you typically find that your facility is actually underlit. So that can lead to safety hazards as well as, making it difficult to actually be productive in your work environment. So continually having to maintain your lighting is really a distraction and negatively impacts your productivity because of what we just mentioned. But because production literally comes to a halt, and there's other expenses, including lift rentals, downtime, and low visual experience, really HID is the worst offender in terms of traditional light sources when compared to the others. So next we'll look at T5 fluorescents, and really not just T5s but also T8s and T12s, but really I guess the best loser out of all of those is the T5 fluorescent lights today. And our joke is really that the T stands for trade-offs. And a lot of people actually made the switch to fluorescent fixtures along the way from HID and hoping to improve their energy consumption as well as address some of those productivity items or productivity downfalls that actually lead to the trade-offs with the fluorescent fixtures. So comparatively, when you look at a fluorescent fixture and you're looking at a comparison to a 400 watt metal halide, your energy consumption, it does have some savings there. So it drops from about 410 watts per fixture, but only down to about 365. So when you look at the energy usage over the year, it's really a savings of only about $50 per fixture. But so there is some savings there, but really they still have a whole lot of downside. And the downside is really driven around the fact that they're still dependent on the lamps. There's still a ballast, which are really those weak components within the system that are still making you have to address maintenance issues, and then they can also impact your productivity levels. So again, they do have a shorter rated lifetime. So, as they do approach their end of life, safety risk increase, and then poor visibility as well, which can actually have lower impacts on morale as well. And just like HID lamps, fluorescent tubes are also omnidirectional. So they're basically putting light out in 360 degrees. So if you're lighting the top of your lighting fixture, that's not the most efficient way for your light to actually be used. So typically you're looking at having to add a reflector or some other way in order to actually get that light out of the fixture. Otherwise, it's lost again to heat, and we all know that goes back again to the surrounding area, and then that has a negative impact on your HVAC system as well. So one of the biggest downfalls in fluorescent lighting, in my opinion, is really the ambient range that they're actually designed to perform in. So most of them are actually optimized at really a 77-degree Fahrenheit application, whereas industrial applications, including light manufacturing, warehousing, and places with higher mounting heights where, heat rises, it can be anywhere typically from 40 C up to 55, and in some applications even 65 C, depending on what's going on within the space. So if your fixture is actually designed to mostly perform at 77 degrees, which is typical for a T8 lamp, when it gets into those hotter areas, you're actually going to lose efficiency and the performance of your fixture as well. So you're either going to have more lamp changes and ballast failures, or while they're on, you're going to have lower than expected delivered foot candles, which typically means that you're not going to be delivering the light that you need in order to accomplish the work in your space that you need to have done. So one last point that I'll make about fluorescent fixtures is, typically, unless you've got a lens as well, these are actually dirt magnets. So a lot of the applications, you've got an exposed or an open bulb, or lamp in the area. And then over time, as dust settles or your manufacturing actually kicks up some sort of debris or air contaminant, that actually builds up on your lamp. So again, that just compounds the problem of actually having the lower than expected or desired light levels within your space. And I guess actually I will add one other comment here. A lot of folks now with the code enforcements and the energy requirements try to actually optimize that energy savings. Some people are saying, fluorescents are great, but let me just go ahead and get them with a dimming ballast or add an occupancy control, which is certainly, a way to do it, but there are downfalls to even those as well. So occupancy controls with a lamp is each time that fixture actually cycles due to non-occupancy or some other event, each time that lamp is actually strike, which can be a number of times in a single day, then that actually shortens the life of the fixture as well. And then dimming ballasts are typically very, very costly, and then they have even more ambient restrictions on them than some of your other light sources as well. So next we'll take a look at some of the reasons why LED it makes a good choice and why now is the time to switch. So I think the way I would describe it is, LEDs really are our friends. And, the reason that they look so friendly or, LEDs are so attractive is because really the disadvantages of the two traditional light sources that we just looked at. So people are continually searching for a way to get around these drawbacks. And really the answer and the only answer is LED lighting. To give a couple of reasons of why LED is really the better way to go is probably the most obvious is they save energy right out of the box. So you can deliver the same performance as a 400 watt metal halide with almost, if not more than half of the energy consumption that you would with a traditional light source. So on top of that, their life rating and their maintenance-free nature actually make them very, very desirable, especially in industrial applications. So typically your best either fluorescent light, you may have a design life up to 40,000 hours, whereas LED fixtures are designed to go up to 100,000 hour mark. So that gives you more time and the confidence to actually focus on what you guys are showing up to work to do each day, and that is to actually work. So on top of those two huge benefits, LED lighting is also extremely versatile. So you're no longer constrained to having these huge fixtures that weigh 70 plus pounds that are HID. There's no longer these monster capacitors that you have to maintain, or there's not a 4-foot fluorescent bulb that you have to actually stock as well because you've got an LED fixture, which basically opens up your design choices to really anything that you'd like to do to be able to accommodate those LEDs. So you're no longer restricted to those traditional light source restrictions. And then probably the one that really makes people perk up the most is with LED, it's instant on. There is no restrike time. There's no wait time. If you need light, there is light at the touch of a switch. And once they're on, because there is no magnetic ballast or electronic ballast, there's not a chance for interference there. There's no hum, there's no buzz, and that of course means there's no headache either. Okay. All right, so we talked really about the energy savings of the metal halide compared to, LED compared to the metal halide and T5. This is really just more of a comparison to show you really how dramatic the wattage savings can be when you go to LED. So you can see there at the bottom, it can be up to as low as 140 watts when you're replacing up to a 400 watt metal halide, which is significant savings. So really, once the LED lighting is installed, the energy savings start right away, but you can also expect to see those increased productivity levels, improve morale, and enhance safety and visibility within the space as well. On top of this, you also give your facility an updated look, and it allows you to actually bring in your customers and show off your process and confidence to the customers that you want to show, what it is that you're accomplishing for them each day. All right, so really, how do you go beyond just the LED light itself? Because that is a significant savings, but really You can even fine tune the capabilities of the LED for your space. You can add simple things like occupancy sensors and controls, as well as some other sensors that would actually help you optimize your energy savings and give you the tunability and customization that you're looking for your lighting. And just to give you an example, just adding a plain occupancy sensor for, say, a warehouse area that turns the lights down to a lower percentage or turns them off for a space that's not being utilized, you could actually save up to an additional 40% on top of your LED lighting savings by just having a simple occupancy sensor. All right, so of course, not all LED lighting is created the same. So what we're going to talk about next is really, some of just the big bucket or key items that you want to make sure you look at when you're actually reviewing your LED lighting. So when you're making your selection, depending on your space, first off, you want to find a fixture that's actually rated for your space and what's going on within it. If you have a higher ambient application, let's just say a 50C application, you want to make sure that you've got a fixture that's going to be able to stand up to that ambient range. Just like fluorescents and HIDs, heat is still the enemy of performance with LED lighting, but really you want to make sure that you've got a fixture that's been UL listed by an appropriate agency to go into that ambient range. And that means that it's got the thermal management that it needs in order to actually survive as well as perform within that space. On top of that, there should also be some ambient factors as well that account for, how much lumen degradation you're actually going to see because you're in a hotter environment. So an LED fixture will put out more light at 25C than it will at 50C is what I'm trying to convey. So when you have that factor, the next one that you want to actually apply to that or multiply by it would actually be the lumen maintenance number. And the lumen maintenance number, what that actually is describing is at what percentage or what point in time will you actually see about 30% worth of light depreciation. So, and that's typically expressed as an L70 at 100,000 or L70 at 50,000 hour mark. So obviously the longer the time frame, the better. So if you ever see a phrase that says L70 at 100,000 hours, that means it's at, at the 100,000 hour mark. That's the point where there should be a perceivable difference in the light levels, as much as 30% that you would actually be able to see or detect the difference in your LED lighting solution. Typically, that's going to be within about a 10-year mark or longer, depending on your run times. Good. All right, so when you combine those two factors together, and really this is the whole point that I was getting to, the reason that you want to be able to evaluate that information is so when you actually lay out the fixtures for your space, you can actually get an accurate description or representation in terms of what are those delivered foot candles going to be like for my specific space at the end of that 100,000 hour mark. Okay. Also, when you're looking at LED, there's a multiple choices. It could be in terms of the quality of light. It could be a 70 CRI or an 80 or 90, and really CRI, what that stands for is the color rendering index, and that's how accurately the light source is actually going to portray the colors within your space. So if you're in a retail application, higher CRI is actually highly sought after because it's going to make the reds pop. It's going to make your merchandise look very, very vibrant. That could also be important in a manufacturing space when you've got multiple wiring harnesses that you want to be able to discern the different colors between. So if you've got a wiring harness with, say, 10 different types of greens because you're putting together a helicopter dashboard, then you want to be able to make sure that your technician can actually see which one is the light green, which one's the dark green, etc. Also important, if you're in a facility with lots of switches and gauges, that's really where a higher CRI than your typical HID or fluorescent light fixture would really come in handy for you as well. And one of the other differences between LED and HID lighting as well as fluorescent that you really want to be able to review when you're making your selection is the transient protection. And the reason that's important is because LED light sources, they're digital. So just like you put your TV on a surge protection or surge bar because you want to protect your critical electronics, LED lighting is the same way. So within an industrial facility, you should see at least 6 kV worth of transient protection in order to meet the IEEE NCC category requirements. But and sometimes you'll actually see a higher surge rating, which is great. But if you see anything below than a 6, then that may not be the best fixture for your application. And a lot of times people are proposing a less expensive solution that's not really rated for the space that you're putting it into. And then ultimately, you want to look and see what their standard warranties are as well. So I'll brag on Cree a little bit. All of our products are actually designed for a 10-year product warranty, and that's not an exception. That is the standard, and that is to make sure that our fixtures can actually run at a 24/7 application for the next 10 years at the highest ambient range that we're offering. Okay, so next I just want to talk about a couple of things that are going on within the industrial lighting space and some of the capabilities that we can expect to see next as the digital platforms continue to grow. So really at this point, lumens per watt or LPW, those are really becoming table stakes. So really the advancements are being built around controls in order to optimize the energy savings even further beyond that lumens per watt or energy savings there, in order to continually meet the strict energy codes and the ever rise of energy cost. And since lighting becomes an opportunity or it gives you the ability to tap into power anywhere, we're continually looking at additional applications that we could actually add additional sensors or provide analytics, including equipment monitoring and other abilities to monitor the activity going on within your space. Okay, so this last slide here, and then we'll be wrapping up for Q&A. This is just two examples of two very common fixtures that we have here at Cree. This is the KBL for your mounting heights up to 25 to 30 feet and delivers a one-for-one replacements for a 6-lamp T5 fluorescent or even a 400-watt metal halide. And you can see this delivers up to about 150 lumens per watt. Whereas the next one is more of your replacement for a one-for-one replacement up to 1,000-watt metal halide, and also delivers up to 140 lumens per watt. And one of the other reasons that I'll just mention here why lumens per watt is really an important metric that you want to review as well is, depending on the energy cost and the energy provider that you have for your area, and the space that you're actually installing in, sometimes those higher LPW numbers will actually correlate into a higher level of rebate as well. So with that, I'll wrap up my presentation. And if you guys have any questions, then feel free to ask.
Thank you. Thanks, Ryan. This is Ann Cosgrove back on, and I want to thank all the attendees for your attention, and for those of you who have sent in questions, please feel free to send in any additionals, and we'll try to get to all of them. So thanks again, Ryan. That was a lot of good information you covered there. Before we get into a few of the more technical or specific questions, I do want to just address one of the service-related questions we received, and that was asking about Cree, and does Cree self-perform projects 100%, or do you also partner with third-party project management firms to install your LED lights in the industrial sector?
So we do have some turnkey solutions available. We can certainly lay out applications for you in terms of and make lighting recommendations for your space and get you lined up with some people to actually do the installs. It's not actually Cree employees who are actually making the installs themselves, if that's your desired effect, but we do have the capability to help you coordinate that if that's desired.
Great, thank you. So then we'll jump into a few of the systems and product related questions. Can you talk about, mentioned ballasts and how the kind of other types of lighting use ballasts. So are LED bulbs that use the existing ballast in a retrofit situation, I suppose, are they a good LED solution? Or I guess what is the role that an existing ballast can play in an LED lighting retrofit? Does it come into play? Can we reuse ballasts, or what's the best advice there?
I think it's okay for a short-term solution. I think a lot of people are going that way. because their desired effect is to have the benefit of the LED. However, I only think it solves half of your problem. And really what I'm getting at is certainly an LED bulb or lamp would last longer than a fluorescent one of the same sort, but your limiting factor there is still going to be the ballast itself. And there's only two types of ballast, and those are the ones that have failed and the ones that are going to fail. So if you still have that weak component driving your system, at some point or another, you're still going to have to drag your lift out and make that ballast change. So really, to get the best performance from an LED fixture, you're best off with having one that's designed as a fully integrated system that includes an LED driver as well as an LED light source as well, or light engine. And then that way you've got something that was intended to work together that's going to give you optimized performance.
Thank you. And speaking of optimized performance, you had talked about temperatures and temperature extremes that are often found in industrial spaces, maybe not all high bay spaces, but definitely I would think warehouse and manufacturing and some other spaces like that. Can you just mention, again, I'm not sure if you touched on that, what your LEDs are rated for in terms of extremes, what temperature ranges?
Sure.
Pre-product.
So the two that I just showed there at the end, the KBL, the one there on the left, the smaller one, that one can go up to 50C, 50C in terms of the temperature range, whereas the larger one can actually go up to 60C.
Okay. Can we see those again, just to have them on the screen?
Sure. Let me see if I can. I'll have to scroll back through, but I can get to that real quick, or hopefully I can.
Okay. Well, while you're getting to that, I will, let's see.
There we go.
Another question here. Great. I just wanted the attendees to be able to see what you were describing there.
Absolutely.
Okay. So then also, let's see, color rendering index. So where you're talking about obviously being able to see some accuracy in whatever the assets are that are being illuminated. So can you talk about what the typical CRI color rendering index of a metal halide or other HID fixture might be, and then how does that compare to LED replacements?
Yeah, so good question. So HID covers both metal halide as well as high pressure sodium, and I'll use high pressure sodium so we can cover the extreme. So probably on the best day for high pressure sodium, your CRI is going to be in the 20s. Which basically that means everything is going to look yellow, or you're not going to be able to tell what color anything is. A dramatic improvement over that would be the white light of metal halides. And typical CRI for those is going to be about 60 to 65. Whereas when you go to an LED fixture, your CRI, you actually have the choice to select, but the typical buckets that you'll see are going to be either a 70 or an 80 or a 90 CRI. At Cree, we do give you the ability to actually select, any CRI that you'd like between those three, but most of our performance has actually been baselined off of an 80 CRI offering because we want to give you the best quality of light for the space. And comparatively, 70 CRI, it's been fine forever, but you can see that there is a trend where people are looking for that better color rendering so they have a better quality of light within their space, and they can more easily discern what's going on between the various colors and actually make their facilities pop.
Great, thank you. So on that quality question and environment question, we have something that came in that's asking about gym lighting. So when replacing gym lighting, is it almost as good to just replace the HID bulb with an LED high wattage bulb after removing the ballast, rather than replacing the whole new LED fixture?
So I think there's been improvements in that, but at the same time, it's a tough one to answer is why I'm struggling with it, and that's because it really depends on how well they made it. And my concern is if you don't have a designated LED driver in there, or you've got something that's just good enough to run your LED bulbs, is it going to be able to also cover your ambient range? And then on top of that, what is the lifetime of that? The good news about the KBL as well as the HXB is when you go and you look at a metal halide fixture, by the time you've taken it apart to put in just the bulb, you probably could have switched out the entire fixture just as quickly because they do make for easy retrofits. Most of the applications, especially within a gymnasium, are going to be a hook and a cord. So it does not take a whole lot of time to take one off of a hook and then put in a new twist lock plug and then be on your way to the next fixture.
Thank you. Thanks for that. And then on to AI. I think we have time for about one more question. So I'll wrap up with this unless we get a few more in lieu of handheld control, this is back to lighting controls, and you had shown some Cree capabilities, I believe, earlier in the presentation. In lieu of handheld control, does Cree have an app which can let local users control their environment through smartphones? Can you talk a little bit about the options there as far as controls in your product?
Yeah, so we have capabilities of both. You saw the hand control up there earlier, and we do have the ability to do that with a remote control and really, have an easy setup. We are looking at other solutions now for more connected lighting solutions via Wi-Fi and mesh network that would actually be accessible to actually program via really anywhere that you had internet access. So that could be from your phone, it could be from your tablet, it can be from your computer, anywhere that you can actually access the internet, you would actually be able to control those lights as well. And that's not available today, but it will be here in the next up and coming quarter.
Great, thank you. And actually, I do have a question for you before we wrap up, Brian. What is in your experience and your team's experience, what are some of the maybe pitfalls or common things that facilities people overlook regarding high bay lighting when they're looking for a retrofit? Is there just some kind of general insight you'd like to provide that maybe you hear or see that maybe help our attendees go away with a better sense of how to evaluate their current lighting?
Sure. Well, I think probably the most important thing is what I was trying to cover earlier is making sure that it's a fixture that's going to perform within the space that you actually have. So if you have, let's say, a food processing facility, you want to make sure that you do have something that has, at least an IP65, if not 66 IP rating on it, or ingress protection, as well as a food safety label. And really that's the extreme to make sure that, you have a fixture that's designed to stand up in the challenges of the space that you have. If just any fixture will work, I would say probably one of the biggest pitfalls is really letting the price drive the decision. And that's not to say that that's not an important part of it, but at the same time, you've got to make sure you're looking at the long-term solution and the other things that are tied to that. So you want to make sure that if you're getting a low price, or that you're letting that be a big factor, you have to ask yourself, okay, what kind of warranty am I getting? What is this fixture going to be doing in terms of, 5 years from now and 10 years from now? Is it still going to be standing up to the test of time? Or, did I get such an inexpensive fixture that, I'm going to put it up and then a year and a half later, I'm going to have to put it up again, which kind of defeats the purpose of LED lighting. And really, what that speaks to next is, who is the company that is actually providing the lighting? Are they local? Do they have a national presence? Are they going to be there as well? So if something does go wrong, I have a reputable company to call back and help me troubleshoot and actually come to a solution to make sure that my LED lighting is up and running versus somebody who came along and sold you some inexpensive lights and then you can't ever get them on the phone again. So those are some big bucket areas that I would say be cautious around, and just making sure that you're dealing with a company that you have confidence in when making an LED investment.
Well, thank you. Thanks, Ryan. I appreciate that. And thank you for your presentation today, and also to Cree for sponsoring the webinar. Thanks to our audience for your attendance and for your good questions that you sent in. I would like to let you know that a recording of this webinar will be available online at our website at facilityexecutive.com, and it'll also be available at Cree's website if you'd like to check out their offerings further, and that's at cree.com, CREE.com. Thank you, and have a great afternoon.
All right, thank you.